Hello everyone, my name is Harnit Saini. I am Assistant Professor in Ajay Kumar Garg Engineering College. Today the topic of discussion is Warshall'S algorithm. This algorithm is used to find the transitive closure in relations. When a set is given and number of relations are given, we can derive some relations using the transitive closure, and for that we use the Warshall'S algorithm. So let's start with it. Now let us suppose there are four variables given A, B, C and D. The arrows are representing the relation that A is related to B is related to D is related to C and D is also related to A. Now from this whole relation we will be making this matrix. Okay. Now A, B, C, D. A, B, C, D. These are the vertices. Now, there is a relation from A to B. A to B we will put 1 here. Then there is a relation from B to D. B to D we will put 1 here. D to C we will put 1 here. Then D to A we will put 1 here. Right? All these relations will be represented with the 1 and all the left out relations will be represented with zeros. Now, with this matrix we have to derive the other relations which can be possible depending on these relations. So, this is the derivative matrix, but how we arrived to this matrix, let's check with the algorithm. Now, this Warshall'S algorithm is that when you are seeing the rows and the columns, we have to highlight some of the first rows and first columns, and then we have to check where there is 1, we will not touch that 1, and where there are zeros, we have to check that zeros. If the corresponding column and the row has 1 there, we will replace that 0 with 1, right? Now, I will explain it with the help of example. Now, see here. Suppose we are highlighting this kth column and kth row. Okay. Now, we have to check all these values here and here, here and here. We have to check only zeros. If there is 1, we will not touch them. Only zeros. Suppose there is a 0 here, right? And we will check the corresponding row and the corresponding column value. If this is also 1, this is also 1, we will replace this 0 with 1, right? See here, we will replace that 0 with the 1. This we will do for all the rows and all the columns and for all zeros, okay? Now, let's see. Now, this example we have written in the form of matrix. First of all, we were highlighting the first row and the first column, right? Now, we have to check this 0. For this 0, here it is 1, here it is 0, so we cannot change it into 1. Now, we check this, here it is 0, here it is 0, 0, so it cannot be changed to 1. Similarly, for these, here it is 0 for all these cannot be changed. This one, here it is 1, here is also 1, so we can replace this 0 with 1, right? And for this 0, here it is 0, so it cannot be replaced. So, we have made only one replacement, that is this one, right? Now, we will highlight the second row and the second column, right? We will check this 0, here it is 0, here it is 1, cannot be changed, 1 and 0 cannot be changed. 1 and 1, so this can be changed to 1, right? So, here this 0 will be replaced to 1 here. Now, we will check this 0, here it is 0 and here it cannot be replaced, 0 cannot be replaced, 0 and 1 cannot be replaced, this 1 and 1, this can also be changed to 1. Right. So, with the second matrix we are converting to third matrix and we have replaced this one and this one, right. Now, we will highlight the third row and the third column, right. Now we are left with these zeros. 0, here it is 0, cannot be replaced. This 0, again 0, 0. These are all zeros, so no replacement can be made in this one. So we will take it as such only. Now we will highlight the last row and last column, right? Now we will check for this 0, right? Here it is 1, here it is 1, so this can be converted to 1. This is already 1, this 0, here 1, again this can be converted to 1. Then for this 0, 1 here, this can be converted to 1. For this 0, again 1 is there, so it can be converted to 1. Similarly for C, this one, this again 1, this will be converted to 1, right? So for these zeros, here it is 0, so they cannot be converted. So this is the final transitive closure for the given relations. So this way it is the easiest method to convert, to find the transitive closure, right? Now let's take one more example. There is a set A with elements 1, 2, 3, 4. These are the relations given: 1, 2, 4, 3, 2, 2, 2, 1 and 3, 1. So let's make the matrix 1, 2, 3, 4, right? 1, 2, 3, 4. This way we can make a matrix. Now first relation is 1 and 2, right? 1 and 2 we will put 1 here, 4 and 3 we will put 1 here, 2 and 2 1 here, 2 and 1 1 here, 3 and 1 1 here, right? Rest all the values we will be taking zeros. In all them we will make the full matrix, right? Now let's highlight the first row and first column, right? Now we will check, again we will make the matrix, new matrix. This way we have drawn it. Now we will check this one. This row will go as such, right? The highlighted row and column will go as such. This one will go as such. For this 0 we have to check now. Here it is 1 and here it is 0, cannot be replaced. This 0 here cannot be replaced. This 0, we have 1 here and 1 here, so this can be converted to 1. This is again we have in 0 here. For this 0 we again having 0, so these cannot be replaced. Now for this 0 there is 0, this row there is a 0 here, so this row will not change, so we will keep it like that only. Now we will be highlighting the second row and second column, right? We will make the another matrix now. Right. Now we will check this 0. Again we have 1 here, we have 1 this side and 1 this side. This can be replaced to 1. The highlighted column will be as such and the highlighted row will be as such. Okay, we have to not touch this. Then about this 0, there is a 0 here, so it cannot be replaced. For this 0, there is a 0 here, we cannot be replaced. Okay, this is 1, we will keep it as such. For this 0, there is a 0 here, so cannot be changed. Again there is a 0 here, we cannot change this. Now for this one, again there is a 0 here and this is 1 and this is 0. Okay, only one replacement we have made in this matrix. Now we will go to the next step. right? Now we have to highlight the third row, third column and third row. Okay. Now these 1 1 will be like this, and the highlighted ones will be as such, right? The ones will not change, we will write ones only. Okay, this will not change. So there is a 0 for this 0, we will check there is a 0 here, so cannot be changed. For this 0, there is a 0 here, we cannot change, this is there. And for this 0, again there is a 1 here and there is a 0 here, so cannot be changed. For this 0, there is a 1 here and there is a 1 here, so we can convert it. Here for this 0, there is a 1 here, again there is a 1 here, so we can convert it to 1. So in this matrix, we have made 2 replacements. Okay, now we will be highlighting the 4th row and 4th column, right? We will make another matrix now. One, 2, 3 and 4, right? So this is our last matrix. Now we will get the final result in this, right? Now we can see here that we will not be changing the ones, we will write as such, right? We will not change the highlighted ones, we will keep it as such, right? Now we have to only check these zeros. We can see there is a corresponding 0 in the highlighted column, so these will not be converted, so we will put zeros here. Now this is the final transitive closure for this given relation. So we were started from here and we have derived this transitive closure from this one, and we can see that we have created more relations which are hidden in that, and with this transitive closure we are able to calculate it. Thank you very much.